We could not hear you, Shiva.
Hi, Dhruv. This is Tariq. I hope you can
Hi,
hear me.
Tariq. Yes, Tariq.
Good to see you.
Yeah. Julian, we cannot hear from you yet.
Hi, Dhruv. Can you hear me now?
Yes, perfect.
Great.
We are at 10:30. So, Julian, whenever you think we should start, go ahead. 10:30 my time, so sorry. Sorry to make you all jealous.
Yes. So, hello, everyone. Good morning, good afternoon, whatever. Good evening. This is the Past Computation Element Working Group session. Welcome to Bangkok. So, I guess everyone should be aware of the usual not well. Basically, very brief summary, everything that you may say, share, or comment during the IETF meetings are subject to the not well and the associated IPR policy. So please, if you aren't familiar with those, look at the pointers that are included there and make sure that you understand and follow them. Next, please, Trev. Okay, so I guess that Harry is already taking minutes using the CodeEMD tool. If you want to give a hand, I think you should be able to access if you have a that Rocker account. So feel free to help Harry if you feel like it. We're Thursday already, and this is it isn't the first online IETF meeting, so you should be familiar with the Mythical tool. But short reminder that you have a tool to manage the queue. So in case you have a question, you join the queue, and Drev and I will give you the floor at the time we feel ready to hear your comments. And remember that we're on record, so as usual, start your speech by including your name before you give your comment. As a reminder as well, so this is the kind of substitute to the face-to-face meeting to discuss topics and create some communication between working group members. But keep in mind that we also have the mailing list that is open 24/7, so feel free to use it even after the meeting if there are some unresolved questions or pending issues. The mailing list is still there anytime. Next, please. Usual also reminder about the working group processes, especially during calls for draft adoption or working group last call. To judge about the consensus on the document on decision, we need to see as much as visible views and opinions on the mailing list. So make sure that when you have something to say, you write it down using an email, and try to get involved in as much as adoptions or working group last calls as much as possible. This is very useful for the chairs. Even feel you think that your point of view is already similar to someone else. Adding yours is always useful to gauge about the interest or the lack of support for new topics or stable ideas. Next, please. So we have a wiki. It's been set up for a while. It includes very useful information about the various queues of documents that we manage. Feel free to read it and possibly update it in case your document has been mistakenly added in the wrong place or forgotten or has made progress that isn't reflected in the wiki. It's available on a sharing tool as well. So it's supposed to reflect some of the documents that we have in our various queues. So make sure it reflects the current state. In case your document isn't in that position, you may help in updating that wiki. Reminder about the early code point allocation. We see from time to time some requests for code points on documents. We manage early code point allocation only starting from working group IDs, not on individual drafts. There are some prerequisites to request allocation, and we have a process to follow to trigger an early code point allocation. Make sure that you have gathered all the preconditions before you request an early code point allocation, and as soon as everything is okay, we'll start the associated process if the working group agrees with that. So keep in mind that this is something that may be worth the effort on some cases, but not always, because it also has a couple of drawbacks. So make sure that in your case, it makes the sense that you expect, and we'll reflect those in the wiki as well. So you may also have a look at our current list, which is empty so far. Agenda. So it's been shared for a while, but usual question, does anyone has anything to bash on the agenda? I don't see anyone in the queue, so we'll assume that it's okay, and we'll proceed with this agenda. So, Dhruv, you want to take the floor from there?
So we have two RFCs since IETF108. We had the Diversity Association and the LSP scheduling RFCs published. We have one RFC which is waiting in the RFC editor queue. Currently, it's misref to the IDR flow spec documents. So once we have that, this will get published as well. We have the association policy that we did the working group last call, and we have sent this to our AD, and we are waiting for routing directorate and AD review to further progress these documents which are beyond the working group. During the two meetings, we processed 3 erratas, both on stateful PCE and PC initiated documents. These were pretty straightforward. We posted the resolution on the mailing list. There wasn't any complaints. So after discussing between chairs and AD, we have gone ahead and verified all of these. There is a early IMA allocation that we made some time back, which is for association policy. Good thing is that's already out of the working group, so everything is good. So if you have any other document and you need code point allocation, as Julian was saying, we have a process. Please follow that. Oh, sorry. So regarding liaison and communication, this is an ongoing liaison with ITUT to multiple working groups. If you remember from the last time, we had an update of some of our documents as they are changing in all these working groups. So we updated the status of those documents. So that is an ongoing liaison that will continue. If you have any comments on it, please use our mailing list and provide any suggestions with handling this liaison. Scott Mansfield is coordinating across various working groups, so you can also reach him as well. Okay, so the next part is we will go over quickly the status of various working group IDs and next step. If you have any comments on these, you can join the queue and provide any update. I've captured what's there in our wiki and what's the status that we know. So if you have some updated information, please come to the mic and tell us. So the documents which are post working group last call, we have the PCCC document. The Shepherd review was done by Julian. Authors have made the update. There were further 2 comments from Julian that authors are saying today morning that they will be handling it. So all's good. I think we would be able to send this out of the working group pretty soon. Regarding the bidirectional association, the Shepherd review was posted. We are still waiting for an update and response from the authors. So if any of the authors have anything to update, please go ahead. Otherwise, use the mailing list. We are waiting a response from you. Okay, seeing, yes, Rakesh, go ahead.
Yeah, this is in my next in to-do list. So hopefully next week I can get back.
Perfect. So the document which is nearing working group last call, this is the PCE Yang document. There are 2 open issues that are listed in the draft. One open issue is related to how do we identify in the T-Yang model which of these LSPs are PCE initiated. So that's one thing that we haven't resolved. That's been listed in as an issue for a long time. So it will be good to get that resolved as well. Another issue is the use of LSP ID as a key, which is a reference to the T-Yang model. So as you know, in PSEP, we have other path setup types as well. So when it is non-RSVP-TE, how do we handle this LSP ID as a key is an issue which was recently identified. So this is something that needs to be figured out. So what we will do is we will start a email thread on the mailing list. And if folks have any ideas on how to handle this, that would be pretty useful information. So please provide that information on the mailing list. We also noticed one thing that we have an SR policy Yang model in Spring. We currently don't reference it. That's a pretty new model, and it will take some time to progress as well. So I personally feel that it might not be a good idea to add a reference to SR policy Yang in this document. We can do it as an augmentation in another document. We have, for instance, SRv6 Yang document. We can make it generic and include both SR policy as well as handling of SRv6 in that ID. So again, this is something that would be good to discuss on the list. We will start a thread on that. Apart from that, the T-Yang dependencies are progressing. We have a dependency on TLS. So if from netcon document, those documents are also in the pipeline. So they will be progressed at the same time as this document is getting ready. We have done a very early Yang doctor review. Maybe we should evaluate if we should do that again at the same time while we are thinking of as this document needs working group last call. If anybody has any comment on any of the Yang model stuff, floor is open. Okay, moving ahead. Please use the mailing list. I think that would be the better place to discuss this as well. Okay, so some of the other documents, we had a stateful GMPLS document. There has been no update since the last IETF. If you remember, we did a merging between 2 documents, stateful GMPLS and PC initiated stateful GMPLS. We combined that into 1 document. So most of that combined work is done. There is one thing pending, which is the implementation status. And since the document is expired anyway, we need a new revision and moving this work along. Any of the authors, if they want to say something, please, you can. Otherwise, I'll go ahead. Okay. The next one that we have is the native IP. This one had multiple versions and rework between the two meetings. Request would be that we should keep the working group in loop and not just mention that the update has been made, but also explain why the changes have been made. So that's something we need to take care in this document. Also to note that in T's working group, we have a related T's ID. Deborah has just asked the T's working group to look into whether the document status needs to change from experimental to informational. So if you have any thoughts on that, please use the T's mailing list to discuss that. We should also evaluate that what we should do about the PC document status. Right now, it's a proposed standard. So we should also at the parallelly evaluate, and maybe even the T's working group discussion should be an input for us to evaluate what should be the status of the PC working group extension. As well as we need to coordinate with the IDR working group related to any of the BGP stuff. So for facilitating that coordination, it will be good to have maybe a BGP consideration section that describes things that the IDR working group should look at. So they don't have to go through the whole document. We can condense and say that these are the BGP consideration that we are introducing as part of this extension. So please look through and provide your comments early on rather than at a later stage. I see Aijun in the queue. Aijun, go ahead.
Yeah, thank you, Joe. We will try to make presentation in next meeting for the change of the draft, because there are some things we are still in the discussion, and for the BGP consideration, we after the stable of the draft, we will seek the opinion from the IDR working group, and we want to also do the update based on the IESC review for the framework document. So after this work is finished, we can update the PCEP extension draft accordingly. Thank you.
Okay, thank you, Aijun. The next document is the enhanced error document. This one had an update. The update moved the scenarios to the appendix, which was a good suggestion, and that's been accepted by the authors. They have also updated the guidelines for other documents, how to use enhanced errors. So I think the document is progressing. If anybody has any comments, I think please use the mailing list to provide that. The next document that we have is the FlexGrid document. There was an update. They added an implementation status section. The core of the document has not much of the change. So please feel free if anybody has any comments for any of these documents. Otherwise, I'll continue to go on. The next two are actually on our agenda, the SRv6 and binding set, so we can skip them. We have next two documents, which is the VN association, which had a keep alive update, and we had the SR path segment that also had a keep alive update. So if the authors thinks that their documents are stable, they have nothing pending, they can let the working group know about that as well. Next, we have SR bidirectional path. This one had an update. They added a scope clarification. They also updated based on the changes in the RSVP-TE bidirectional document, so which is always good. They updated the figures, notations, for clarity. So thanks for that. The last document here that we have is the segment routing SR policy candidate path association. So the update was focused on changing in the reserved value of association ID. There was a mailing list discussion last week regarding the new procedure to mandate PCC's allocation of association parameters. So that's ongoing. If you have thoughts on that, I think please use the mailing list. and provide your thinking. And we are looking forward from authors an update on that. Okay. Finally, we have a recent working group document. This was recently adopted. There was a comment to can this procedure be made more generic, whether we do this in this ID or via a future mechanism that needs to be established. So if you have any thoughts, please discuss on the list. So I would expect authors to provide an update on that as well. And I see Andrew is here. Andrew, go ahead.
Comment. I hope it didn't actually upload as that. But the document was labeled as local protection enforcement. It originally was listed as path protection, and then we renamed it to local protection. So I'm not sure if it's just the slide is not correct or if it actually uploaded incorrectly.
I need to check. I'm not sure. So
Okay.
Good. Thanks for pointing it out.
Thanks.
Okay, so final slide from the working group status is what's our adoption poll queue. So these two documents have been pending in our adoption call. So we will be taking up these documents, PCCC SR document and stateful interdomain document. Many of you have made your request. Those requests are tracked in the wiki in the link that you see. So if something is missed, if something is incorrect, please reach us and we will update that. This queue is growing long, so we need to start moving it. So to help us, I would also request that, like, when we do the adoption poll, please do respond. That helps us even moving your documents early on, right? So it's like, when we do the adoption call, we are looking for feedback. Please provide feedback for all the working group documents in last call as well as adoption. And that's it. And if there is no other comment, we'll start with our agenda. Okay. Mike, you are next.
Hi, everyone. I'm Michael Koldyshev. I'll be presenting this draft, carrying binding SID label, segment ID, and PC-based networks on behalf of the authors. Next slide, please. So I think we all kind of know what a binding label is, or binding SID is. It's basically attached to a policy or a tunnel. And this draft defines this T-path binding TLV. In this TLV, there's something called there's a numeric field called a binding type. And this binding type basically, it controls the value of the binding value. So for binding type 0 and 1, the binding value is an MPLS label. For binding type 2, the binding value is a SRv6 SID. And so in this new iteration of the draft, we define the binding type 3, which causes the binding value to be an SRv6 SID plus some extra information for carrying endpoint behavior and SID structure, as we'll show in the next slide, if you can go to the next slide. So as part of SRv6 network programming, SRv6 binding SIDs can have endpoint behavior and SID structure. So we simply add these pieces of information to the end of this binding value after the actual SRv6 binding SID. So there will be like an SRv6 binding SID, 16 octets, and then this extra information. Next slide, please. And we also added, kind of unrelated to this SRv6 stuff, we added the S flag and the I flag. So the S flag specifies that if you cannot allocate the requested binding SID for a particular policy or a tunnel, then that policy or a tunnel has to be invalid. So it means like you must use this binding SID. And the I flag is like kind of invalidation drop behavior. So it basically means that this tunnel or policy must kind of so sorry, what I mean is like BGP traffic that is normally steered into this policy, it's always steered into that policy, even if the policy doesn't have a path. So in that case, the traffic would just be dropped. Next slide, please. And that's it for the updates. So we can discuss some questions or next steps. Thanks.
Any comments from anyone? Yeah, go ahead, Tariq.
Mike, this is Tariq from Juniper Networks. Thanks for the updates. I have a question on the binding SID new type. Currently, you can download one. Is that correct? Is my instruction one binding SID for one tunnel or one
Yes.
SR?
So yeah, thanks for bringing this up. So we actually changed that as well. That was another kind of update. Was that we allow for multiple binding SIDs now because
is that for MPLS as well or just SRv6?
We allow it for MPLS as well.
Okay, I like it. Okay.
Mm-hmm. Thanks.
Huaybo, go ahead.
Yeah, this is Huaymo from FutureWay. I have a question. So for the binding type, you have 0 and 1 for MPLS label tunnel. So why do you use two values, 0 and 1 for one type?
Sure, yeah. So basically, 0 and 1 is to differentiate the other fields in the MPLS 32-bit label, such as the EXP bits and yeah, I think it's just the EXP bits. So basically, I think like BT1 means that you can control the EXP bits in the MPLS label, and BT0 means that you only want to specify the actual 20-bit MPLS label, and you don't care about the EXP bits. Does that answer the question?
Yes, I think maybe if you can get more details in the, is this details in your document?
Yeah, it is there for sure. Yeah.
Okay, that's okay.
It's basically the difference between putting a 20-bit label versus putting a 32-bit label.
I would say 32-bit label stack entry. That would be the right way to say.
Right. Mm-hmm.
Yeah. Okay, I'm not seeing anybody else in the queue. So thank you, Mike. I think the document is making good progress. We wanted to check with you since all the comments. Oh, I spoke too soon. Boris is here. Boris, go ahead.
Thank you. Morning. Mike, one question. In recent SR policy draft, where we added so-called composite path, do we need to reflect it here somehow or not?
It's not going to be in this draft. It's going to be in the PSEP multipath draft. So this is just for carrying the binding label, and the binding label is really unaffected by the whole composite policy addition. So this draft will not be affected by the composite policy, but there is another draft called PSEP multipath for SR policy, which is going to be which is where we're going to find
clear.
Yeah.
Thank you.
Mm-hmm.
Hi, Mike. I think even the SR Policy Association might be something that might change for that as well, right? Not just the multipath document.
No, I don't think so, because it's basically you just need to carry the color instead of the ERO to support this composite policy. So the candidate path will have, instead of having like a segment list of labels, it will just have a color. And that's all that's required to support, signaling this composite policy.
Pawan, go ahead.
There might be some changes in the SR policy as well. So there are multiple ways of addressing it. You could have two constituent SR policies having an association saying that they both belong to the same parent policy. So we will discuss that on the list and address it. But yeah, you're right. There could be some changes in SR
Sure.
policy.
Yeah.
Thanks, Pawan. So coming back to the status of this document, binding SID. So Julian and I discussed, we think that the document is making good progress. We wanted to check with the authors. What do they think about the status of the document? Is it ready for last call? That's the question to you, Mike.
A little bit more. We can wait until maybe the next one to decide that.
Okay, perfect. Thank you. Cheng, you have comment?
Hello?
Cheng, go ahead. Cheng, go ahead. Go ahead.
Oh yeah, I agree with Mike that we can wait for one more meeting to see that do we have any further extensions on binding seed, right?
Okay, thank you.
Yeah.
So I think you can stay on for the next presentation as well.
Hello guys, Cheng Li from Huawei. My topic today is about PCP extension for SRv6. So next please. So we make the presentation last time in IETF 105. So from that on to now, we have updated document from revision 0 to revision 7. So this slide talks about the update of from 0 to 6. So basically, we have defined the following extension for SRv6 in PSEP. So we add a new part setup type in the part setup type compatibility TLV, which is the SRv6 pause. So also we have added a new SRv6 PCE compatibility sub TLV to specify more detailed information like MSD information for SRv6 pass. So we also introduced the new PST for SRv6 in RP and SRP object to specify the pass computation requirements and reply, right? So the most important part is that we introduced a new SRv6 EL sub-object, and we rename the field of C type to an AI type, NT for short. So also we update the SRv6 R subject. You can see the format in this slide. So next. So at last update, which is from 06 to 07, we make a major update of the draft. We add a new sub-TLV called C structure TLV to align with the extensions in ISIS and BGPS and BGPS policy draft, right? So as you can see here, we pasted the updated format, encoding format of the SRv6 EL sub-object with seeds list here. And as you can see, we also introduced two more flags into this sub-object. The first one is T. T means that when T is set, we have an optional 8-byte C structure when the SRv6 is included. So we have to make sure that the S bit is unset right now when the T bit is set. So also we introduced the V flag into this sub-object for seed verification. So and the usage is the same, identical to the section 5.1 of SRv6 of the segment routing policy. Also, one comment here: do we really need to add the A flag here? I see another document to specify to carrying the algorithm information in two more new like NAI. I think that will be presented in the following topics, so we can discuss this. So next, please. So this slide describes the details of the seed structure sub-TLV. As you can see here, we used 8-byte TLV to describe the format of the seed structure instead of 4. The reason is that we think the 4 bytes seed structure of it is too limited because we can only describe like 4 parts of the SRv6 seed for now. But what if we have more like parts or more like attributes of the SRv6 structure, and we have no like further bits or reserved fields to like describe that? So we introduce like 32 bits reserved fields for the future usage, right? So that is the main thing. So next. Okay, the plan of this draft is that we are going to update the document a few times, and then when the document is ready, we will request for working group last call. But I don't think right now is the right timing. So comments are always welcome. Yep, that's all.
Any comments? So I think,
okay.
as Cheng was mentioning, we have the next talk, which will have which will describe about algorithms. So we can take up this question about whether we need an extra flag or not. One comment would be that between the two documents, the binding SID and the PCEP SRv6, where the SID structure is added, if we can align the SID structure between the two documents, that would be good. Like it should be same format in at least in the PCEP. So that I would request the both authors to discuss and put a common SID structure format for both binding SID and SRv6 ERO.
Okay, cool. Got it.
Another question, this is not directly related to SRv6, but this V flag is something that we don't have for SRMPLS also. And this is a question that we should evaluate, that as you know, SRMPLS, we already have a published RFC, but we don't have this V flag. And if we are adding it to SRv6 ERO, maybe we find a way also to update the SRMPLS and add the V flag somewhere. One option is even the next document that we are discussing, the algorithm one. Maybe in that document, if this V flag can be added as well. So just a question to the working group regarding this as well. If anybody has any comments. Okay, moving right ahead. Mike, are you going to be presenting?
Actually, Samuel was going to present, but I think he's not here. So I can be a backup presenter here.
Perfect. Thank you for doing that.
Sure. So my name is Mike Koldyshev from Cisco. I'll be presenting this draft, carrying SID algorithm information in PCE-based networks. Next slide, please. So the motivation is that we kind of have two things we want to do. First, we want to signal a constraint to the PCE to say that we want to compute a path using a particular SID algorithm. And the second thing we want to do is, once that path is actually computed, we want the PCE to send the ERO, and in the ERO to specify the SID algorithm of each SID that it put in the ERO. So this draft basically allows you to do those two things. Next slide, please. Yeah, so basically there's like this prefix SID algorithm is kind of IGP thing. So there's two default or two kind of basic algorithms defined, SPF and strict SPF. They're 0 and 1. And then there is something called flex algorithm, which is ID 128 and greater. And flex algorithm allows you to have like any kind of constraints in there. So next slide, please. So the way we signal the SID algorithm used by a given SID is we define a new NAI type for that. So NAI is the node or adjacency identifier. And basically we define these two new NAI types for IPv4 and IPv6 node SID with algorithm. And so basically this NAI carries a little bit of extra information to encode the algorithm. And so, yeah, next slide, thanks. And this is the other part of the requirement, is that we want to have a computation constraint to say that we want a particular path to be computed using a particular algorithm. And so this TLV is put in the LSPA object to basically specify that constraint. So for example, if you want to compute like a path using flex algorithm 129, you can attach this TLV. And there's like fallback flag and loose flag to say if you're allowed to use other algorithms in the path. Next slide, please. Yeah, so just comments and suggestions, and we would like to request work group adoption for this one. Thanks. Hello?
While I was saying all this, sorry about that. Jay, go ahead.
Hello?
Yes, go ahead.
Okay, this is Jidong, and I have read the document, and I think it provides the segment times which are defined in the SR policy. Thus, I think this is a useful extension. Some comments. One is about the L bit. I think in this, it is not clear to me whether different prefixes with different algorithm can be put in the same like a ERO for one pass.
Mm-hmm.
Is that allowed or not? Different algorithms in the same pass. If you cannot meet
I think if you specify this loose flag, then it is allowed to insert another algorithm, like a prefix SID with another algorithm.
Yeah, but can different prefixes with different algorithm be used in one, for one SR pass? I think this may be something can cause a loop if it is allowed.
Like, you mean, can I specify to use like prefix, or sorry, like algorithm 128 and 129, or are you saying like to specify, okay, use algorithm 129 if you can, but if you can't, then fall back to some other algorithm?
Yeah, my point is for the prefixes in one pass, you maybe need to restrict them to use a consistent algorithm. If they fall back to one, then they should not use different algorithm.
You think that can cause
may cause a loop?
That can cause a loop?
Yeah, different algorithm used in one pass may cause a loop. Yeah. Now, this is my first comment. Another one is maybe a general comment about the PSAP SR, because I see that in PSAP the SR segment types are described in a different way from the SR policy in BGP, right? I'm not, so maybe it's better to check whether there's still some inconsistency between the two mechanisms in the meeting the segment types defined in the SR policy document in Spring Working Group.
Yeah, they are quite different. We use in PSAP, we use this like NAI encoding.
Yes.
And in BGP TE, they use different types of SIDs like A, B, C, D up to K or something. And yeah, they are quite different, and it's probably too late to try to unify them.
Yeah, need to align. Yeah.
It's probably too late, to be honest, because a lot of the stuff is...
Yeah, the format can be different. I mean, for the different segment types, you need to make sure that each one has been defined for both SR BGP SR policy and the PSAP SR extensions. Yeah.
Yeah, I think we definitely should go through them and make sure that they have equivalent in either in either format.
Yeah.
So just to add to what Jay was saying, I think since we have found one issue with the algorithm and we are fixing it, we can use this opportunity to find anything else that is misaligned, and in one document itself try to update. For example, even the V flag thing that we were discussing in the previous document, can we use maybe this document to also add the V flag for SR MPLS? Just an example.
Sure, yeah.
There is, before I go on with the queue, just since we are on the same page, I think this LSPA part is not very clear because we are not sure whether this algorithm is to be used as end-to-end path algorithm, or is it just while you are picking a particular SIDS, you prefer algorithms, you prefer prefix SID which uses this algorithm. That part is missing even from the presentation and the document. Not very clear. As you know, we have an OF, which is an optimization objective function, which is supposed to do like, minimum delay path, which is an end-to-end objective function. Is this algorithm going to replace that, or is it just adding to that? So please do take care of that part as well when you are describing LSPA.
Okay, point taken. Thanks.
Tariq, go ahead.
Tariq with Juniper. Maybe you were faster than me to ask the question, so but I'll reiterate it in a different way, Dhruv. So if you're crossing multiple domains, you might want to say in domain 1, I want algorithm 128, and in domain 2, I want algorithm 129, and in the third domain, you want a different algorithm. There is an implicit assumption here that the algorithm is end-to-end. But indeed, every domain can define, let's take an example, the low latency flex algo to be 128 in domain 1, and it can be anything else in domain 2 and domain 3. So you might want to open up the possibility to have multiple or an algorithm per domain. And I don't know how we can talk how the details of it. How to specify in a domain the algorithm, but I don't see it end to end. It's hard to,
Yeah, I'm not sure how you would encode, how you would specify like per domain algorithm.
Yeah.
If you have
Maybe
any
we can
suggestions,
take it offline. Yeah.
Yeah.
I'll think and I'll reach out offline. No problem.
Yeah, thanks.
Loa, go ahead.
Yeah, can you hear me?
Yes.
Yeah.
Okay. I have a question on the number of things you can do from one algorithm. I read the draft, I thought I understood, but when you presented, you gave an example where you can do two different things in the same algorithm. Is there a practical limit to how many things you can do?
Not 100% sure what you mean by two different things. What I was saying is that you want to specify, you need to be able to specify a flex algo computation constraint. That's one thing, and you need to be able to specify that a given computed ERO hop is of a particular flex algorithm. Those.
Oh. Are those the only two things we can do?
Well, I guess, yeah, that's.
So let's imagine that we figure out something else we want to put in there. Is it possible with the current format?
I'm not sure exactly what you mean by like something else. Maybe if you can give just like a very hypothetical example.
Yeah, I'm not.
I mean, this is kind of for a very specific purpose, right? To carry, you know, flex algorithm, either constraint or result.
So let's say you have more than one type of constraint. You have a minimum bandwidth and a jitter. Can you put both of them in there?
You may be able to mix like a flex algo constraint with another constraint. Like, for example, you may be able to say, use flex algo 128, which is like a latency flex algo, and also try to exclude some affinity, maybe, I don't know. And so it may be possible to combine, you know, different constraints like that.
Okay.
That should work with.
I think I need to reread the draft and take it to the list.
Yeah, the constraint basically says that the way the draft is worded, the constraint says that the head end says, you know, I want my path to be computed using a particular flex algo. Say
So,
flex algo 128.
For example, could you do things like excluding nodes?
Yeah, you should be able to. Yeah, you should be able to encode that.
But then we have more than two, don't we?
Yeah, you can have more than two constraints for sure. This is just one constraint, right?
Yeah, that's what I want to hear. So there is no practical limit to how many constraints you have.
Yeah, for sure not. This is just adding one extra constraint, right, to the PSEP protocol. It doesn't mean that all the other constraints are not allowed to be used with this one. They can still be used. Yeah.
Okay. Thank you.
Yeah.
Thanks, Loa. Huaimo, you are next.
Yes. So regarding to looks like you allow each prefix seed have a different algorithm. That means in one domain, for that path, we can have multiple different algorithms, right? One maybe for delay, one maybe for bandwidth. So that looks like we have a consistency at least in one domain, right?
Well, not necessarily. Like, for example, if you're optimized, like say you request a path just optimizing latency, right? And you have a flex algo, a certain flex algo that optimizes latency. Even though you didn't request that flex algo, because it fits with your constraint, the PCE may return you a path using that flex algo. So
is that allowed, for example, in one domain, and then we have multiple prefix seed, and then for each of them, maybe we can use different algorithm?
Yeah, that's
at least
perfectly
we should
fine.
have a consistency, right? Some kind of maybe this algorithm is in one group, in one domain. So different algorithm, but this different algorithm is from one group. So that makes sense with the most, at least to some extent, those algorithms is consistency to some extent.
I don't think there's any problem with using, different algorithms either within a domain or outside of a domain. Like you may have a 0 algorithm SID followed by 128 algorithm SID, followed by 129 algorithm SID. If it helps you reduce the label stack size and make use of equal cost multipath, I don't think it causes any problems. There may be some. I'm not sure you brought up the point of loops. If you can come up with a particular example where a loop can happen if you chain different algorithms like that. But it would be up to the PCE controller to compute a path properly, to take care that it doesn't cause loops.
Yes, maybe it's too loose or too flexible. And at least we should have some check whether this so with different prefix, with different algorithm, at least we have some kind of a check whether this different algorithm at different point, there may be some kind of a consistency to some extent. We cannot just use different algorithm for this prefix seed, and then next is another algorithm, maybe totally different one.
Well, why not? I mean, we can discuss that. I don't believe there's any reason why you can't use that.
Yeah, I think this is best for the mailing list now. So we have. Let's take up with the next person in the queue. So Pavan, go ahead.
Juniper Networks. There is definitely value in having the ability to specify, say, different sets of constraints or different optimization objectives for a given domain, for an inter-domain path, right? So, so in RSVP, at least, we have this notion of hop attributes where you can provide a set of attributes associated with a given hop. So in the inclusions, today in PCEP, the problem is we don't have that notion of hop specific or a domain specific attributes in our inclusions. So if we can bring in that construct into PCEP, I think you'll be able to address your requirement where you say, while traversing for this computation in this domain, use this set of constraints. For the next domain, you specify the next domain ID as your inclusion, and then give the hop attributes associated with that. We can talk about it on the list, but yeah, there are ways to address this.
Yeah, maybe we can somehow have like a way in PCEP to say that to give like an identifier for a domain, and say like within this domain, like some
that exists today, like Drew was trying to say, but we don't have a way to specify attributes associated with that domain or constraints or optimization objectives associated with that, and that's probably the missing piece. And there's an object available in RSVP that can be borrowed to address this.
Okay,
Thanks,
that's
Pavan.
cool. Yeah.
Jeff, go ahead quickly, please.
So I would say concatenation of algos would be okay. So logical end. For example, you want to optimize towards slow latency and disjointness. Logical OR, however, is not, especially within single domain. Intermixing nodes from different algos is not a good idea. But there's idea of continuous connectivity within an algo, right? So I would be really against using it this way. It's more on gut feeling than scientific right now, but
like I'm sure there could be counter examples to to cases where it's bad. But yeah, I mean, there could also be, examples where it's useful. So I don't know. I'm not either for or against it. But the encoding is there. So like if your PCE server wants to encode it, it is there.
So from document perspective, I think we need to provide text specifying scenarios where it's safe to do so. And yeah, so if something can go wrong, it will go wrong. So we need to protect consumers' information from breaking things.
Yeah, that's more kind of a vendor implementation of the algorithm, right? Like, each vendor has to, make sure that their computation algorithm results in a safe segment list, right? And, if your PC computes a segment list that can result in like loops or something like this, or then it's kind of, the implementation's problem, in my opinion.
No, it's not our job as people who develop standards is to remove ambiguity. And please do provide clear text as how to do it. And if you cannot, probably you should remove it.
Yeah, let's take this now to the list. I think thank you, Jeff, for excellent suggestion. We are taking up time from the next presentation. So Xiangji, if you can take your question to the list, and there's a lot of good discussion already on this document. So thank you for that. Let's move on to the next presentation.
Thank you.
Huban, are you here? Yeah, go ahead.
Yes, I just doing a voice check. Can you guys hear me?
Yes.
Perfect, thank you. So my name is Human Bitgoli from Nokia. I'm presenting the PCE SR point-to-multipoint policy. Next slide, please. So with regard to this presentation, I'm just going over the high-level view of what the point-to-multipoint policy is. I'm not going to go into the nuts and bolts. You can read the draft. I just want to make sure everybody understands what the idea is and where we are trying to go with this idea. Now, there were multiple drafts, including one in spring, which was the replication segment, and one in PIM, which was the SR point-to-multipoint policy. Around 5-6 IETF ago, I did present this draft in the PCE, but back then, these replication segment and the point-to-multipoint policy drafts were not adopted. As such, we put this draft on hold for adaptation on the PCE working group until these two other drafts were adopted. So as of now, they are adopted. There is a third draft that is the draft PREG MVPN, EVPN, SR point-to-multipoint. We were asking for adaptation for that too in BESS, and I believe as of yesterday, that draft got a good support and it was adopted as well. As you can see, there are other drafts to make this solution complete, which you can have a look at if you would like to learn more about it. Next slide, please. So why this idea was put on the table? The basic idea is on the unicast side, obviously we are moving away from the complex protocols like LDP, RSVPT, and we are trying to simplify the network with the underlay IGP and then overlay BGP. That creates an issue for multicast. Obviously, when a vendor takes away these MPLS protocols for unicast, they don't want to let them linger in their networks for multicast. Multicast being the more complicated beast of the two. Obviously, they want to do the simplifications on the multicast domain as well. So this is how this idea was evolved by coming up with the very simple method to program a point-to-multipoint tree through a network, whether that network is segment routing network, or even if segment routing is not there, we could program this point-to-multipoint tree throughout the network to connect a route with a set of leaves. Next slide, please. So the very first concept of this idea is what we call the point-to-multipoint policy. Actually, it's not a segment, it's a policy. My apologies, I need to correct that. So what is a policy? You can think of a policy as a root and a set of leaves, and it's really identified by the root ID and the tree ID. Now, the root ID and tree ID is the basics identification of any multicast tree within the network. Even if you think about MLDP or point-to-multipoint RSVPT, that's how we identify a tree within the network. So under the point-to-multipoint policy, you could have multiple candidate paths. Think of candidate paths as a redundancy for your point-to-multipoint tree. So you can have a primary candidate path that is active, and you can have multiple other candidate paths that are inactive, and there is a preference, and the one with the highest preference is the active one. Under the candidate path, there are two path instances. You can think of the path instance as the actual point-to-multipoint LSP, or the forwarding entity. The reason that there are path instances is basically for optimization of the candidate path. So if there is a break in the network and the candidate path needs to do a global optimization, it creates a second path instance. The PCE programs a second path instance through the optimized route from the root to the leaf, and it does a make before break on the head end to switch from the previous unoptimized tree to the new optimized tree throughout the network. There are multiple ways that you can configure this point-to-multipoint policy. You can do PCC initiated. What that means is that the MPBGP procedures that are in RFC 6514, 6513, you can look at the route types. You can figure out where are the leaves, what leaves want to join the point-to-multipoint tree, and based on that, you can update the PCE from the PCC with all this information, tree ID, root ID, and on the leaves. Or you can do PCE initiated. What the PCE initiated is, you go on the PCE itself and you create your root and the set of leaves, and you assign your tree ID, and then the PCE downloads the information to the PCC. Next slide, please. So that was the policy. That was what identified the tree on the head end, on the root. Now, obviously, we need to forward the packet, the multicast PDU, from the root to the leaf, and that's where the replication segment comes in. So the replication segment really has the label information, the forwarding information, the protection information, etc., etc. Now, one thing we need to keep in mind is a replication segment is really an idea of multicasting a packet at a specific node. Two replication segments really can be connected via a unicast segment routing domain as well. So the entire idea is not let's put replication segment one after another to forward these PDUs through the replication segments, but it's very flexible that you can have replication segments in specific places in your network where you want to do the replication, and you can connect these two replication via a unicast SR. So it really plays very nicely with the unicast SR, where there needs a need for the unicasting between the two replication segments. There are two types of replication segments, and I want to be very clear about this one. When it comes to point-to-multipoint LSPs or MVPNs, a tunnel, a point-to-multipoint LSP, represents the VRF itself. When you look at unicast, you have the upstream assigned BGP label that actually identifies that VRF. When you go into multicast domain, the tunnel itself can actually bind the root VRF to the leaves VRFs. So that's one of the biggest difference between unicast and multicast. So this is why we have a replication segment that can be identified with root, tree ID, and the LSP ID, which will identify the VRF. But there can be also an aggregation replication segment that will actually connect the root to the bunch of leaves, but the verb can be actually identified by an upstream assigned label. Now, this mode of behavior is implemented by some vendors, but as I said, as of now, the most common way of doing this is connecting the point-to-multipoint LSP into the verb. So that's one thing that we need to keep in mind implementing this draft. Next slide, please.
Human, you have a bunch of slides still, and we have around 2-3 minutes of your slot left. So
I'm not
do a
going to
little
go
bit.
through them.
Yeah.
I'm
So
not
just
going to go
cover
through all
that.
of them.
Okay, go ahead.
Thank you very much. So can we go to the next slide in that case, please? So just to give you a little bit of a heads up how this works in the PCC initiate example, as I said, MPBGP will discover the leaves. The root will discover the leaves. The root will send the update message to the PCE. PCE, based on the BGP-LS states that it has, builds the tree from the root to the leaves, and it actually uses the PCEP protocol to download this replication segment and the point-to-multipoint policies all the way down to the PCEs and builds the tree and actually binds that tree to a specific verb. Next slide, please. So this is just a very high diagram of all the informations that are there. Oh, no, one slide back. Sorry, my apologies. Yeah, so this is, again, I explained the point-to-multipoint policy. I explained the candidate path, why the path instances are there, and I explained what the replication segments are there, and the fact that 2 replication segments can be connected via a unicast SR policy. Now, for the rest of the slides, those are just some examples that you guys can go through and actually can have a look at them and try to understand better some of the concepts that we are trying to bring into this draft. But basically, the main point that we are trying to put on the table here is that there are multiple vendors working on this draft. There are some implementations already out there. Some of the vendors are in the midst of implementing this draft. And we wanted to make sure that the group is aware of that. And if you go to the last slide, please. Right. So we are open to any comments, and what we are hoping to do is actually adopt this draft for more comments, obviously coming up on the next IETFs.
Huaibo, go ahead.
My understanding is that this looks like a PC controller. So for SR P2MP policy or whatever path, so PC needed to send the instructions to each of the node along the P2MP path, right?
So as I said, the PCE needs to send the information to the paths that are trying to do the replication, because 2 replication segments can be connected via a unicast SR. But you are correct. The nodes that are trying to do the replication needs to have this information, correct?
So in that case, so for each P2MP path, we have states in the network, right? So this seems not a consistency with the philosophy of SR routing or whatever segment routing, right? For segment routing, the idea is that we don't have any states in the network. So for this case, we can see that we send the instructions to each of the node along the P2MP path, and then those states stay in the network, right?
Right. So good point. That battle was already fought in the Spring working group, and the draft was adopted on the Spring side. But to answer your question, basically a segment on a point-to-multipoint segment on each one of nodes creates a replication segment. So without the replication segment, you don't know what are your outgoing interfaces. So you're going to go, in this case, you're going to go from A to C, which is the next segment in the replication point.
Just to add on to what Huaimo was saying, I think, of course, that battle, I think we can move on for that question. But I think with respect to PC extension, we have a concept called PCCC, which is PC as a central controller. And that was developed especially for cases where PC needs to send instruction on nodes which are not the head node. So especially in your case, when you have to send instruction to the branch node or to the leaf node, I think the PCCC technique and use of CCI object would have become a better extension to PCEP protocol than what is currently being described in the document. And if you remember, we discussed this in the past as well when you last presented this in the PC working group, and that concern still exists.
Noted. So we went down the path of the CC object, and at the end of the day, we felt that the ERO object, the way that we are using it, was a fit for this idea. So you're absolutely right. As of now, we are using the ERO object to download the forwarding information. But yeah, like as a group, as a team, that's the path that we went down.
Yeah, I think like let's have that discussion on the list. It's
Sure.
not just the matter of ERO object, it's actually the whole framework that we came up with, the whole framework of when PCE is interacting with non-head nodes. These are the framework and the architecture and various things in the PCEP protocol that you should take care of. So I think those are still valid. It's not just the matter of whether we use ERO object or CCI object. It's the framework that I'm more worried about.
Sure, we can discuss that for sure in the...
Okay, I think we have taken our buffer time for the meeting has been taken. So let's move to the next document. Thank you for presenting.
Thank you.
Shuping, go ahead.
Can you hear me? Okay. Hi, this is Shuping from Huawei, and I'm going to introduce the set of PCE-CC drafts. Next, please. So first, a quick recap. So we have the RFC 8283 that defines the PCE as a central controller, and it also examines the PCEP as the SDN source-bound interface. And for this draft, the PCEP extension for the PCE-CC, it specifies the basic PCEP extensions for the static LSB. So as the chair has already introduced, currently it's post-working group last call, and it has been reworked after the Shepherd's review. Here, we would like to thank to Julian for the excellent comments to us. And also today, in today's morning, we also replied to this further review, and we will give another updates on this draft to further resolve the comments. And very briefly about the recent changes. So we reordered the sections with the PCE initiated the script first, which is also aligned with the common case in the case of PCE-CC. And we also have defined an explicit flag, that's an L flag, in the PCE-CC capabilities PRV. The next, please. So basically, for the further PCE-CC extensions, there are two parts. One is segment routing, including both SRMPRS and SRv6, and also P2MP. So those are last discussed during the IETF109, and they have been added in the working group adoption queue. Next, please. So in the following slides, I will introduce each of them separately. Now, first is about the PCE-CC for the SRMPRS. So this draft and uses the PCEP to allocate the SRMPRS label on all the nodes in the SR domain. And we defined a new CCI object tag for SRMPRS, and as well as a new FAQ object. And here are some recent changes. And we also align and synced with the other drafts. And we reused the PST equals to 1 for SR. And we have also added new flags for the adjacency seed. And we also did some editorial cleanup. And it has been on the working group adoption queue for quite a while, and it has been overtaken continuously by other drafts. So now we would like to request to issue the adoption call. Next, please. About the PCE-CC for SRv6. And this draft uses PSAP to allocate SRv6 seed on all the nodes in the SR domain. And we defined a new CCI object type for SRv6. And for the recent changes, we also aligned and synced with other drafts. And we reused the PST equals to 2BD and for SRv6. And we also added the new flags for the adjacency seed. And we also did some clear up. And currently there is no other open issues. Okay, so for this PCE-CC for P2MP draft, it uses PSAP to allocate the label instructions on the branch node for static P2MP LSP. So it allows multiple CCI object for the replication at the branch node. And again, we also aligned and synced with other drafts. And for example, we reordered the section as well, and as well as some editorial changes. So again, there is no other open issues. Next, please. Yeah, so we would like to request for issuing the adoption call, and thank you. So any questions?
Any questions? Okay, thanks, Shuping. Oh, there's Aijun. Aijun, go ahead. Aijun, go ahead.
Okay.
Yes, we can hear you.
So after your introduction, we know that the PCC for MPS and the PCC for SIV6 just for the seed allocation. You know, I think it is may make some person so confused with PCC for PCE for SR policy. So can we think some method to distinguish them? You know, these two drafts just only for the seed allocation from the PCE and not related to the policy. So, so can we, you know?
So yeah, Aijun, are you suggesting a draft name change or title change?
Yeah, yeah.
Okay, I think we can take that into consideration. Shuping, what do you think?
Yeah, sure. We can discuss about it.
Thank you. So let's move to the next presentation. Thanks, everyone. Go ahead.
Yeah, hello, this is Giuseppe. Can you hear me?
Yes, yes.
Okay, okay, very good. I'm presenting on behalf of the co-author, and this is the PSAP extension to enable live feed. So next. Yeah, firstly, just a few words about background and motivation. So we already presented this during the last IETF. And we also had some discussion. Basically, yeah, the IP terms refers in this case to data plane on path telemetry technique. So inbound OM, in situ OM, and alternate marking, and you can see the reference document for both this methodology. And the PSAP extension defined in this document allow to signal these capabilities in order to enable these methods and to automatically activate them. In particular, we aim to generalize these IP attributes to include these TLVs to be carried as LSPA attributes. So next. Yeah, in this slide, we want to highlight the changes after the last IETF. In particular, the draft has deeply changed because you may recall that the first version was applied as TLV to the association groups, while this version extend this definition and applied TLVs for all path types and is applicable to LSP attributes. So thanks, Drew, for this input. In this way, we have generalized this application, and the SR policy is now a use case of this draft. Additionally, we also got other comments, in particular, the suggestion from Fengwei to add different IFIT capability flags. In this way, each capability can be advertised separately, and this was already addressed in the current version. We also had other inputs from Waymo, so thanks a lot, and we also improved the draft to produce a new section about the PSEP messages and procedures for handling this TLV. So we added more details about that, as well as the example of application to SR policy that, as I mentioned before, is now just a use case. So next. Yeah, the PSEP extension for IFIT attributes, as I said, the TLVs are now carried inside the LSP attributes object and can be applicable for all path types. So, of course, these TLVs are optional and can be taken into account by the PCE during path computation and by the PCC during path setup. They can be carried within a PC initiate message, a PC update message, and a PC state report message. In the case of SR policy, of course, these attributes also complement the PC segment routing policy CP draft. So next slide, please. Yeah, one before. Okay. Yeah, we introduced the IFIT capability advertisement TLV. So this is an optional TLV in the open object for capability advertisement. So you can see the usual TLV format and 5 bits that we introduced in flags field to signal each capability and each IFIT method separately. So you can see 1 bit, 4 bits for IOM option flag and 1 bit for alternate marking flag. So of course, if it's set to 1 by PCC, the flag indicates that PCC allows distantiation. If set to 1 by PCE, the flag indicates that PC supports distantiation. But anyway, it must be set by both sides to allow the IFIT support. So next slide. Yeah, this is the IFIT attributes TLV that is included in the LSPA object, and there are several sub-TLVs that are supported and that are showed in the next slides. So next, please. Yeah, this slide shows the 4 IOM sub-TLVs that are supported. Of course, the reference is from the IOM data draft in IPTM. So you can see all the IOM pre-allocate trace option, incremental trace option, directly export option, and edge to edge option, sub-TLVs. Next. This is the sub-TLV for enhanced alternate marking. Also for this, the reference is the RFC 321 and the draft in 6 months. Next. Next slide, please. Yeah, I lost the connection.
Same here.
Hello?
Drev, are you still with us?
Can you hear me?
Screen.
We can hear you.
Sorry about that.
Yes.
What, the disruption only from me or?
Yeah, I
or
think
for
you got
other?
dropped.
Oh, sorry. Let
Can
me
you
share.
resume sharing, or do you want me to do it?
Hello?
No, I can.
Okay.
Sorry about that.
Yeah. I
Can
can
you hear
see your
me?
slides now. Yeah.
Okay.
Please
Okay.
resume your speech.
Okay, thank you.
You have the floor.
Yeah, I was mentioning that, yeah, this is the alternate marking sub-TLV. So the reference is the RFC 321 and the 6-month draft. So next. Yeah, this is what I mentioned before as an improvement after the IETF 108. So we details how these TLVs are included in the PSAP messages, and also the example of application to SR policies to complement the segment routing policy CP draft. So particular for PC initiated the LSP with IFIT feature enabled, these attributes must be included in the LSP object in the PC initiate message. After the instantiation of the LSP, also these attributes can be included in the PC report message to provide the status. And when the LSP is instantiated, the IFIT methods are applied as specified in the corresponding data plane document, and you see the reference. Of course, to update, to disabling, enabling this feature, the PC update message can be used, and the IFIT attributes can be included there. Next slide. Yeah, we want to continue to collect feedbacks. For example, we got some offline discussion with Mike about the multiple segment list signaling based on the new draft that they are working on. Yeah, of course, these TLVs can be extended also for multipath TLVs as they are defining. So let's see how, if there is a use case, we can also mention this in our draft. Anyway, we aim that the working group can evaluate the adoption of this work as base document for this. And yeah, of course, other questions and comments are welcome.
Fabrice, are you in the queue to ask a question or for the next presentation?
For the next presentation.
Okay, then Mike, go ahead.
Yeah, just had a question about the general IFIT architecture for SR policy, whether there are use cases where you could have different tracing options for, different tracing options per segment list of the SR policy candidate path. As you know, the SR policy candidate path, it has multiple segment lists, right? And I kind of imagine you could have different tracing options for each segment list potentially. I'm just wondering if that's been included in the actual architecture of IFIT, like outside of PSAP.
Yes, this is, as I mentioned, yeah, this is something that we can consider as, I don't know if it's a use case that can happen very often, but in any case, if we can refer your draft, and we can say also that these TLVs can be applicable in that case, yeah, for multi-segment list case. Yeah.
Sure, and I think the same thing has to be done for BGP equivalent of this draft. I believe in there you also put the sub-TLV at the candidate path level. So it maybe should be possible to put it at both levels if you're gonna do that. Thanks.
Yeah, thank you.
Thank you. So I think we can move to the next presentation.
Okay. Thank you, bye.
Fabrice, go ahead. Yeah, go ahead.
Hello everyone, I'm Luke Fabrice Ndifo from MTN Cameroon, and I'll be presenting to you the support for Path MTU in PSEP on the behalf of the co-authors. Jove, next slide please. So on this slide, I will try to give some sort of a motivation or some background generally why we think about that in PSEP. When we're looking at the traditional MPLS, the Path MTU could be signaled by, is being signaled by RSVPT and LDP, as you can see in the RFCs that I mentioned. But now when we go to segment routing paths, we don't have any additional signaling for, for Path MTU. And we currently, we need that support. What we can get, excuse me, from the SR is information gotten from BGPLS, and that is being used by PC to calculate paths. When packets are being sent, two things can happen. If it is below the MTU size, it can go through, or if it is more, you have it being fragmented. And this is a major concern when it comes to operator networks, but because it affects greatly the quality of service. So with all this put in place, we thought it necessary that it is important to do this extension in the PSEP message. Next slide, please. Now, this slide basically focuses on the metric object for Path MTU, how that is to be managed. We have the, for this support of Path MTU, we have the B bit, which is supposed to be set. And now, when this bit is set in the PSEP message, then now the Path MTU can be used as a condition or as a constraint when we want to calculate paths. So we have the T field, which is still a field that has to be determined by IANA. Next slide, please. Now, for this slide, it basically gives what happens when we take this into consideration, the Path MTU amongst other constraints that we can have between the PCC and the PCE. So what happens is when the PCC has already selected the PCE to communicate with, the PCC can send a path computational request message to the PC with constraints. Those constraints, it can either be you have the source address, the destination address, you can have the bandwidth, you can have the setup, the whole priority. And in addition, we have this Path MTU, and you can see that the B bit is being set to 1. So just to say that that is a field that has to be looked in the message. Now, when this PCE has sent this request to the PCE now receives and computes successfully to satisfy the constraints that have been put in the packet. And now, focusing on the PCE, when on the Path MTU, it looks at this parameter, and it can get back with a response message telling the PCC that, okay, I've gotten a successful path that you can use. And now you can also have a case where this path, a successful path, or a condition, the conditions are not fulfilled. And now the PCE will get back to the PCC and indicate the conditions that led to the failure of getting a candidate path. And now you can have you now then have the PCE initiate message, which is used by the PCE to ask the PCC to set up a new LSP, as well as provide the path MTU calculated for the path. So that is what now the PCC would use to forward now the packet. In this slide, it is also important to mention that this new metric path of a type for path MTU is applicable for both SRT path and does not require any additional extensions. Next slide, please. This is actually a draft that was being presented in the IETF 108 session, and we received a lot of comments which we have tried to amend. And amongst those comments were, for example, trying to bring definitions for some of the terminologies that sometimes cause confusion, like the MTU, the link MTU, and the path MTU. We also have the path MTU adjustment session that has been added to include the case protection for TI-LFA. We did some few editorial changes. And next slide, please. We think that this is a candidate for workgroup adoption, and looking at how important this is, I think that is a next step that we need to look at, and we are open to questions. Thank you.
Thanks, Fabrice. Mike, go ahead.
Yeah, I think it's a good draft, first of all, like it's useful. I wanted to make one comment. So again, as you know, the SR policy candidate path can have multiple segment lists, right? And,
Yeah.
you know, those segment lists may have a different path MTU. For example, you may have like 3 segment lists, and one of them has like a large MTU, like say, I don't know, 2000 or whatever, and another one has like a smaller MTU, like 1400. So in that case, you know, I noticed that your path MTU is per candidate path. So in that case, you would have to report the lowest, the minimum of those, of the path MTUs of the constituent segment lists, right?
Exactly.
Yeah, so it might be useful to also report the path MTU of each individual segment list separately as well, in case the head end is able to kind of send different size packets to different segment lists.
Okay, yeah. I think that
I'm
is
wondering
noted,
if
Mike.
people
Yeah.
think that's useful. Yeah, thanks.
Yeah, thank you, Mike. It's noted.
Cheng Li, go ahead.
There's associated with CPs, which is presented by an ERO object, right? So as we have defined this kind of...
Cheng, we can barely hear you.
Yeah, I can't really hear.
Cheng, yeah, go ahead, try speaking.
Okay, how about now?
Still a bit low. I think you are using your laptop speakers. I will ask Jeff to maybe go next while you figure it out, and I will give you audio next. Jeff, go ahead.
So I have a question, how useful is actually in segment routing use cases? The real constraint is amount of seats that we can impose. And MTU is kind of implicit to that, right? So rather than knowing the amount of bits you can push, you're not going to fragment anywhere, right? The use of MTU is going to be eventually used to looking how deep your seat list is. So I think MSD provides enough information to compute constraint path. I'm not sure you really need MTU for that. Just thinking aloud.
Hello,
Yeah.
guys.
Okay.
Yeah, I could like to answer to Mike's question. Like, as Mike could note that we have defined the similar solutions in BGP as a policy, and that path MTU is associated with the seed list. So I think there's extension in PCP drafts that would be identical. So yeah, it would be associated with the seed list. Yep.
No, I understand what you are saying. The point here, eventually you would need to translate MTU into number of seeds you would be able to push through this interface without fragmentation, right?
Oh, Jeff, we're not going to answer your question. I'm answering the Mike's question. Sorry.
Oh, sorry.
And yeah. So regarding the MSD like proposal, I think it is valid, and maybe we can make more discussion on the mailing list. Yeah.
Sure, absolutely.
Yeah.
Yeah, I think we should just take that note of that and have further discussions on that. Yeah.
Thanks, everyone.
Thank you.
So let's move to the next presentation. Haumian, are you here? I thought Haumian was presenting. Is Haumian not here? Cheng, are you presenting this?
Yes, I'm a backup.
Okay, go ahead then.
Okay. Yep. So, ladies and gentlemen, my topic today is about state synchronization between stateful PCE, and this is the first draft. And in this slide, we were going to present 3 drafts, which are associating to with the stateful PCE. So, next, please. So, roughly, reminding of this draft is that in this draft, we are going to propose the mechanism to synchronize the states among the stateful PCEs, right? So the key concept of this document is that we initiated this sync up PCE sessions among stateful PCEs, and so that we can sync up the incremental LSP states during that session, right? So we also supposed to set primary and secondary PCE for different responsibility. The scenarios of this includes that we can support redundant PCEs to support backup or like load balance. And also we can support the scenarios like inter-domain PCEs or hierarchical PCEs. So and we have make a presentation in IETF 105, and we have got some good support for adoption. So next, please. Hello, next. Dhruv? Okay, so this figure shows that how the mechanism works. Basically, we will have like multiple PCEs, right? So they need to sync up together. So between the PCEs, we will send some like messages to sync up the state among the PCEs. That's the main idea. So next. So that's okay. So the status of this document after the previous presentation is that we make some editorial changes to align with the recent RFC, like yeah. So we also add some like security consideration, And so at this time, we think the draft is stable and mature, so we could like to request for a working group adoption of this document. Yeah. So this all for the the draft. So should we go through all the drafts firstly and then go back to the discussion, or one by one?
I think we can check if any comments on this document.
Okay.
And I see the queue is empty, so we can move to the next one.
Okay, thank you. So the second one is about extension for stateful PCE to allow the optional processing of PCP object. Yeah. Next. As we okay, so the summary of this draft is that we clarified how the P flag and I flag to be used, so it can identify how to process the PCP objects, and I think this kind of flags have been defined in IFC like 5440, right? So it will be introduced in the next slide. So we update the handling of how to handle the handling of unknown objects based on these flags. So next. Yeah, the background the background of this P flag and I flag is that they have been defined in IFC 5440, and the P flag is used for indicating that the PCE must process the objects, and the I flag indicates that you can ignore it, right? So, but in IFC like 8231 and has specified that in the stateful PCE, it can it must be set to 0, and it should be ignored, right? So in this draft, we define the specific processing of these two flags. Next. Yeah. So this slide shows the P flag and I flag usage. I will not go into the details, so let's skip this part. Yeah, this is the whole flow chart of the processing of unknown object, right? So when the P flag is set, it means that we have to process this object. Otherwise, we do not need to. The PCP speaker is free to process it or not, based on its local policy. So if the P flag is set and the object is unknown, then we have two ways to go. If the I flag is set, then how to do that? And if I flag is not set, and the PCP is also afraid to ignore it or not. So next. So the status of this draft is that we get a confirmation of the program statement on the list, and I think we get a consensus about this extension is useful, right? So we also make some editorial changes to think of the recent IFCs after the IETF 105. So in order to progress the document, we request for working group adoption of this document. Yeah.
Are there any questions on this document? Okay, let's move ahead.
Okay. Next.
Are you not seeing the?
I cannot see.
I am on the page which says vendor specific information.
Yeah, right now I can see the slide. So the last draft is about conveying the vendor specific information in PCP extension for stateful PCE, and I think some vendor have implemented it already, right? So next, please. Oh, there are some delays between me and the mid-echo. Yep. So the main idea of this draft is to convey the vendor-specific information between the PCP speakers. So we have make a presentation in IETF 105, and also we got some like good support. Right. Next, please. Yeah, I don't think we can. I don't think we need to go into the detail of this slide. Next. So the main change is that we make some editorial changes to align with recent IFC as well. Yeah, after the meeting, last presentation, and we added the implementation state case from Cisco. And we add 2 more causes as well, and also we request for working group adoption of this document. Yep, that's all. Comments are welcome.
Any comments? From the chair's perspective, we wanted to ask, these documents have been stable since IETF 105. So if there are any objections to progressing them, or you think that they are not useful, now would be a good time for the working group to speak up.
Yeah.
Okay. Julian, you have any famous last words before we end the call?
Nothing famous to say.
Okay, so we give you 4 extra. We give you 4 extra minutes. Enjoy. See you at gather.town maybe. Take care.
Goodbye, everyone. Thank you.